Okay, so our problem today is that we have a board of n multiplied by n, and we start from cell I j, and from that cell Marisa can go to I plus 1 j or I j plus 1. So moving horizontal or vertical, upward. Yeah, and okay. So Marisa journeys start from 1 1 and ends at NN, and she needs to collect the maximum mushroom, so she can go to the right or she go to the top. And okay, and she keep going to the right or the top until she meets NN coordinate. So let's start with our drawing board. Okay, so for our example here, let's say we are at a 1 1 2 2 1 1 2 1 1 1 2 1 2 2 2 1. So she will always end at the position here, and then no here, and then 2. So she collects 2, and she should choose either from the path that ends at here or the path that ends at here. And from this, she also chooses from here or from here. And also from this, from here or here. Okay, so the formula should be that result of dp of I j should be the maximum of all the mushroom collected at dp I minus 1 plus the mushroom that she collects at this position plus 0 raised to I say yep. And that we have the dp formula, so let's get started. Yeah, this problem is quite easy. Okay, so let's create a function because since the constraint is at 10 to the 9th, we need to accumulate the total. So we want to define we need to use a long variable in order to be able to store to not overflow the variable. So the long max mushroom of the board. It will be okay. We need the width and the length of the board, which is the n, which it is equal to board start size. Okay, and yeah, first off, let's process the input data. And next is that we process the array. Okay, let's use okay. All right, and vector in and should be here the value of 0. Okay, now we need to use long, so we will input long for something lesson and plus plus so plus in I say okay, and we have the result. So okay, we will output the maximum mushroom of that board. Yeah, that's the processing of the data. Next, we need to calculate the DP array. Okay, in DP array, let's use a size of n. Okay, let pass it with another layer, another value, so that we can calculate it more easily. No, okay, actually let's not. And okay, so for these two, they can just okay, I still want to pass the array. And for one let's n I plus plus okay, so equal to 1, say less equal to n plus plus. Calculate the dp value equals I j maximum of dp I minus 1 j or p I j minus 1 plus I minus 1. No, it's the board minus 1. Yep, and okay, and the result should be the dp of and yep. It should be long, sorry. And the value for Okay, oops, long. Okay, yep, should be the correct answer. Okay, let's spell this. Yeah, we pass the array so that we don't need to pre-populate the initial value of the first line. Okay, so let me save the answer. Yep. And next, let's go to the second problem of today. Okay, let me. Okay. The second problem. Go fences painting. So we have a wooden fence of N planks. Marisa wants to repaint the fence using two colors, orange and yellow. Okay. So the dominant color of the fences will be yellow with a little bit of orange. Therefore, okay, so the constraint here is that Marisa wants any two orange planks to be at least k planks apart. The distance between two planks at position I and z is I minus z. Okay, so the wooden fence is a 1D array. Is a yeah, and okay, so let's consider there are 8. Okay, we need to count how many ways to paint the fence so that this condition is satisfied. Quite difficult. Yeah, okay, let's take the example. We have input 4. Okay, the fence has 4 length, has 4 planks, and okay, so n equal to 4 and k equal to 2, and we need to count the number of ways to repaint the fence. So we need to okay, so the color orange need to be apart from the color from each other. K planks, and k can be k is at least 1. So okay, so for k 4 we have orange. We can start with yellow, and when we start with yellow, we can keep start with yellow, or we can start with orange. We can just keep with the 4 yellow. Yep. we start with orange somewhere here, or either we start with yellow, orange. If we start with orange, we need to consider how many. Okay, so if we count every possibility, it will be 2 to the power of n ways, which is very bad. So we need to count it efficiently. Okay, so let's for example, from the position y here, from the position yellow here, we need to count how many ways before and then can be difficult. Okay, so we can count how many ways to have the previous value as yellow here, or yellow when this is yellow. We can count this how many ways to have a yellow or orange. Both are valid configuration. But if it is orange, then we need to count like backward. How many ways from okay, so how many ways up to here to have yellow? Okay, so it should be when we are orange here, then here should be yellow and yellow, and should be at least k yellow. So that we can have orange here upward. Okay, so it should be the number of orange and yellow. So, it can be yellow here, cow yellow, so orange and yellow. And here is must be yellow, and must also be yellow. So here contains, so it is possible. Let's draw it again. Let's say that at the terminal state we have the color orange. Then The previous state cannot be orange because it needs to be a K yellow part. So this must be yellow, and must also be yellow here. Okay, that's okay. So here it can be orange. Or it can be yellow. So the number of yellows here is the number of boys to choose orange up to this part and yellows up to this part. Okay, so we can like count the number of yellow, the number of configuration here, I think. And for yellow here, if it is yellow here, then the previous can be orange. Yep, it can be. Or the previous can be yellow. Yep. So it should be okay, the total of both, and it is orange and the okay. So if it is orange, then we count the total of orange and yellows before K values. If it is yellow, then we count number of orange and yellows K values before. Okay, it means yellow. We can count the previous the total of previous orange and yellows configuration, and otherwise it's the K times yellows, K times configuration before. Yeah. Okay, so let's process the input. And okay, and we have modulo here. We need to define the cost modulo. Equal to 10 to the 9 plus 7. N and K, sin of N and K. So we need to count. Okay, so let's go to the vector dp in dp here. It can be can have n values. Yep. Okay, no, let's describe with something more clearly. Yellows and oranges, and so we can build the number of yellow starting at n. How many yellows that can end at ends at the index I. Okay, so we need This is a number of ways that yellows that end at index at a specific index. Yellows 0 is 1, and orange 0 is also 1. But also so for k equal, okay, so for example k equal to 3, let's say k equal to 4, then the starting value can be yellow, not orange, then must also be yellow, yellow, and yellow, and yellow. And when k equal to when it is yellow, then it can be orange here, orange. This one can be yellow, 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 and yellow. So we need to count the ways from so there's this one way here, one. There's one way to have the orange that ends at the index I. Okay. That's okay. I plus plus yellows. Orange. Orange is I equal to 1. Yep. Orange can be here or can be here or here. But yellows on the other hand can be both orange and yellows. Let's start with the special condition first. Okay, so k is also equal or less than n. Should be okay. It's yellow, yellow. I will equal to yellows I minus 1 plus orange. Orange is I minus 1 should be this. And okay, so next let's get to more complex condition. Okay, I equal to k, k less than n. Oops. I plus oranges can be yellows. I minus k plus I minus k. Sounds right. Yep. And finally we count the total numbers of way to have yellow. What? Yellow standard index and -1 plus orange. Okay, let's get our partition function. Return a plus b mod percentage modulo. Minus k oranges and -1 should be here, and let's try it. Okay, let's add nope, let's in is enough. I don't think it's this easy, but yeah, it might be this easy. Nope. Oh shit, I need to use that here too. And let's submit it again. Yeah, accepted. Quite confusing, but okay, so let me explain the algorithm again. So to count the number of so from a position I, and if we count the number of yellows that end at I, then we can just take all the yellows and orange that ends at I -1, because and that becomes a full set of possibility of the yellow, because the before can be yellow or orange, we just don't care. But if it is if here is the orange case, then the before cannot be orange. It cannot. The before that can also not be orange, because we need at least k yellows here. So we need to take a few k steps further, and we count that we can be when we okay, so and k yellow, k times yellow, and here it can be yellow or orange, we don't care. Let's take all, but we need to sum back k values. And yeah, there's only one possibility to choose at this which is always yellow. Yeah, and that's the answer for problem number 2. Let me submit it. update the okay, let me update the task title description. Nope, update the description of this stream. Let me paste the solution here. And that's all. Okay, that's all. I have uploaded 2 problems, and yeah, I didn't start the timer today. Oops, I forgot that. Okay, need to play video game with my friends now. So see you tomorrow or the day after tomorrow. Bye bye.